Cool. So now, if we go to page 34 in our booklet, yeah, we've got this system of equations. So let's try and enter them into our So I've got 2x plus 4y, 2x plus, so wait. So we call this inconsistent equations. All right. And now let's enter those equations. So I've got 2x plus 4y plus 4y plus 2z plus 2z is equal to 4. Second one is x plus 2y plus z is equal to 6. And then I've got 3x plus 6y plus 3z is equal to 10. Wonderful. So this is my system of 3 equations. This is equation 1, this is equation 2, and this one is equation 3. Now, the first thing I always need to check is if I can find a unique solution for this system, okay? And for that purpose, I just enter the coefficients. So I need to solve simultaneous equations. Do I need to show you again? So you go into menu, equations, press execute, then you've got, wait. So menu, equations. What kind of equations you want to solve simultaneous? So press F1. How many unknowns? 3. So we press F2 for that. And we've got them in the form of ax plus by plus cz equals to a constant term. And our coefficients here are for x2, for y is 4 in the first equation, for z is 2, and then the constant term is 4. Second equation, coefficient of x is 1, coefficient of y is 2, coefficient of z is 1, constant term is 6. Third equation, I've got 3 for x, 6 for y, 3 for z, and 10. And now I press solve, mathematical error, press exit. All right, so at this point, my calculator becomes redundant. So what I need to do now is, if I look at this, I can see that I've got here x, 2x, and 3x. So the coefficient in the first one is times by 2, coefficient of x. In the third one is times by 3. Same applies for y. So 2y times 2 is 4y. 6y, 2y times 3 is 6y. So that means that this one times 3 becomes this one, and this one times 2 becomes number 1. Yeah, except for the constant terms. Which are not proportional. All right, so that means that I've got 3 parallel planes. One, that's 1, 2, and 3, which are parallel with each other. All right, so 1, 2, and 3 define three if I have 3 parallel planes, how many points of intersection do I have?
0.
No point or points of intersection. Right now, if I were to try to solve this by, so try solving by elimination. And I've got two x plus 4y plus 2z equals 4. Equals 4. The next one is x plus 2y plus z equals 6. And the third one is 3x plus 6y plus 3z is equal to 10. Yes, and that's 1, that's 2, and that's 3. Okay, and now I take 1 and 2. And I scale to, so I'll do 1 minus 2 times the second equation. Yeah, and let's see what I've got. I've got 2x plus 4y plus 2z equals 4. And the second one times 2 is 2x plus 4y plus 2z is equal to 6. And now if I subtract them, I'll get 0, 0, 0 is equal to 4 minus 6, negative 2. So 0 equals negative 2. That means 1 and 2 don't intersect. The next one, I'll take 1 and 3. 1 and 3. How can I make the coefficients equal? I do the first one, so 1, I look at the coefficients of x, and the lowest common multiple of 2 and 3 is 6. So to make the top one 2x, make it 6x, I'll need to multiply by 3 times equation 1 minus 3x to make it 6x, 2 times equation 3. Yeah, and now I'll have 6x plus 12y plus 6z is equal to 3 times 4 is 12. And the second one, the third one, times 2 is 6x plus 12y plus 6z is equal to 2 times 10 is 20. And now if I subtract them, I've got 0 equals to 12 minus 20, negative 8. So 1 and 3 also don't intersect. Because I've got a nonsensical solution here, yeah? 0 cannot be equal to negative 8. Yeah, and now if I do 2 and 3, so 1 and 2, 1 and 3 don't intersect. The only pair which I've still got suspicions about is 2 and 3. Yes, and I'll have 3 times 1, 3 times 2, so 3 times equation 2 minus equation 3, yeah, and that will give me 3 times equation 2, 3x plus 6y plus 6y plus 3z plus 3z equals to 6 times 3, 18. And underneath I've got equation 3, 3x plus 6y plus 3z equals to 10. I subtract them and I'll end up with 0 equals to 18 minus 10, that's 8. So 2 and 3 don't intersect either.
Wait, sir.
And now,
Sir?
as none of the 3 planes
Sorry, can you hear me, sir?
ever intersect, they must be parallel. All right, and I can now enter them into my GeoGebra calculator and check
Sorry,
to
sir.
see if that is true. All right, so my first one is 2x plus 4y. So 2x plus 4y plus 2z plus 2z equals 4. That's the first one. The second one, x plus 2y, x plus 2y plus z equals 6. And the third one, 3x plus 6y plus 3z equals 10. Yes, and now I can, oops, I can see that my 3 planes are parallel. Yeah. Cool. So I can even take that. All right. And yes, and I can insert it into my, yeah. All right. Cool. Now let's have a save this and let's take another example. So again, we start with, so if we don't get, if the graphics calculator says mathematical error, then that's clearly a case of either I have no solutions whatsoever, or I've got a multitude of solutions. That means there is no single point, unique solution, no single point of intersection. Okay, so that's my first step, checking with the graphics calculator. The next step would be to inspect the coefficients. All right, and as you can see, we said that the coefficients in equation 1 are proportional to the coefficients in equation 2, less the constant term. Again, with equation 2 and equation 3, same scenario applies. The coefficients of the variables are proportional, less the constant terms. So if this one is equation 2, plane 2 is parallel to plane 1 and is parallel to plane 3, that means that plane 1 and plane 3 are also parallel. All right, so by just inspecting them, you don't need to solve. you just have a look at the coefficients and say, look, coefficients of the variables are proportional, but the constant terms are not. That means the three planes are parallel. Simple as that. All right. Now let's move on to another scenario where I have, let me check that one. Okay, so I've got 2x plus, so the first two are the same, so 2x plus 4y plus 2z, 2x plus 4y plus 2z plus 2z is equal to 4. X plus 2y, x plus 2y plus z is equal to 6. And the third one is 2x plus y, 2x plus y plus 5z is equal to 3. Wonderful. Cool. Now, if I look at these guys, I can see equation 1, equation 2, and equation 3. What can you tell me from this? I can say that equation 1 is parallel to equation 2 as variables coefficients proportional. Yes, and now I can take 1 and 3 and 2 and 3. So 1 and 3, and I'll do 1 and 3. Eliminate x by saying 1, in 1 the coefficient of x is 2, in 3 is 2. So I just subtract them one from the other. So 1 minus 3, and let's see what we get. I've got 2x plus 4y plus 2z equals 4, and 2x plus y plus 5z is equal to 3. I subtract them. 2x minus 2x is 0. 4y minus y is 3y. 2z minus 5z is minus 3z is equal to 4 minus 3, 1. Okay, so let's call this equation 4. And now I do 2 and 3, yeah? 2 and 3. 2, and 3. How do I eliminate x? Eliminate the same variable, which is x. Yeah. So I've got number 2 is x, is the coefficient is x. The coefficient of x in number 3 is 2. So I need to multiply equation 2 by 2. So I'll have 2 times 2, 2 times 2 minus 3. Yeah, cool. And I've got 2 times 2 is 2x plus 4y plus 2z equals to 12. And number 3 is 2x plus y plus 5z, and that is equal to 3. Subtract them from each other, and I'll have 3y minus 3z is equal to 12 minus 3 is 9, and that is 5. Now, if I look at 4 and 5, yes, they've got the same coefficients or proportional times 1, yeah, for y and z, but different lines of different constant terms. So that will look like this. So this is, we said 1 and 2, yeah. This is number 1, and then this is number 2, and then I'll have something like this. And this is number 3. And this guy's here. So 1 and 3, from 1 and 3, I got equation 4. That is equation 4. And this line here is from 2 and 3, and that is equation 5. Yes, and 4 and 5 are parallel. Okay, so I've got 1 and 2, plane 1 and 2 are parallel to each other, and 3 cuts them both along 2 parallel lines. Yes, 4 and 5. Do I have a point or a line or anything that where all 3 planes, 1, 2, 3, intersect each other? All 3, do they all intersect somewhere? Come on, someone help. And that means we have no solutions. All right, there are no solutions to this scenario. Okay. Now let's have a look at the third one. Do we still have time? Yes. The third one is going to be, let me see. Third one is what I like to call a tent. So this is parallel planes. I like to call this a shelf. Yeah, it's up to you. You can give it any name you want, but for consistency, you can use my denomination. I've got no copyright on it. So that's a shelf, and this is a tent. All right. So let's have a look at the third scenario, where I've got these guys here. Okay. So I've got 2x plus 3y minus z, 2x plus 3y minus z equals 4. Next one is x plus 2y plus z plus 2y plus z equals 6. And the third one is 3x plus 5y plus 5y equals equals 5. Yes. Cool. So if I look at the coefficients of x, yeah, I've got 2, 1, 3. Over here, I've got 3, 2, 5. Over here, I've got negative 1, 1, 0. So this looks like, so this is equation 1, equation 2, and equation 3. So if I 1 plus 2, yes, 1 plus 2 will give me 3x plus 5y minus z plus z 0 is equal to 10, which is parallel to number 3. Yes. First, before doing all that, I tried the graphics calculator. Yeah. So I've got 2, 3, negative 1, and 4, 1, 2, 1, 6, 3, 5. What's the coefficient of z? Is 0 and 5. So don't forget to, if you don't have, if one of the variables is missing here, that means I've got plus 0 z. Yeah. So if I want to solve that now, again, no joy. Okay. And that's why I need to inspect those coefficients of my variables. Yes. I see that they are not proportional. There's no proportionality between. So if this was, I look at the x's, x1 times 2 is 2x, 2y times 2 would be 4y. Now, x to become 3x is x times 3. 2 times 3 is 6, not 5. And now between these two, I need to multiply the top by 3, the bottom by 2. So the top by 3 would be 6x, the bottom by 2 would be 6x. This one would be 9y, this one would be 10y. So there is no proportionality whatsoever. But I can see that there is a combination between the coefficients of two of the equations and the third. All right. So this tells me that the intersection of 1 and 2. So intersection is a line parallel to plane 3. Yes, so I have these two guys. Yes, this is 1, this is 2, this is the line of intersection, which we can call it 4. Yes, and now the plane underneath here, yeah, this one is 3. Yes, so if these two intersect on a line parallel to the other plane, yes, then we've got a 10th scenario. Yes. Tenth scenario, no points of intersection. All right. Now, one other thing I'd like to mention. So we've been through a couple of I've got this one here. So 1 and 2 do not intersect. Yes, 1 and 3 do not intersect. Whenever you've got, all these are inconsistent. Yes. So for inconsistent, when trying to solve, yeah, you'll get a nonsensical answer like this. Yeah. So let's draw that conclusion here. The inconsistent scenarios are two parallel planes cut by the third, and three planes intersecting like a 10th. Okay, so when trying to solve inconsistent systems of equations will always end up with results in the form A equals B, where A is different than B. Yeah, which is a nonsense. All right, doesn't make sense. So if you're trying to solve them either with your graphics calculator or manually by elimination, you'll end up with something looking like 0, so i.e. 0 equals 5, or 2021 is the same as 2020, when we know that they are not. One was, or let's say alpha equals delta. Yes, not the same. Okay. And that's basically all I wanted to show you for today. I'll turn this off.